morning, dear students. We'll continue the module number 5. This is the second part, that is sampling theory. In the first part, we have seen joint probability distribution. In that, we have completed what is joint probability distribution, how to prepare joint probability distribution table, then what is marginal probability distribution. Then we have seen expectation of random variable x, expectation of random variable y, then expectation of random variable xy we have seen. Then with the help of these expectation of random variable x, xy, we have seen the covariance, then correlation. To find correlation, we have seen standard deviation formula which comes from variance. So with the help of this, we'll go further for the next subtopic, that is sampling theory. Sampling theory, it is I can say that one of the important concept in the statistical tool. So in our day-to-day life, it becomes quite often necessary to draw some valid and reasonable conclusions concerning a large mass of individuals or things. It becomes practically impossible to examine every individual or the entire group, known as population. See, one concept I can say in general. So if you want to go to a shop, so from the shop, if you want to buy almost 10 kg of sweet, so to buy a 10 kg of sweet, so before taking or purchasing, we'll see the taste of that. So based on the small portion of that, or I can say that one part of that sweet, that is only one piece, so we can identify whether we need to purchase that sweet or no. Means I want to conclude that one of the important concept. So what 10 kg of sweet is there, we called it is population. So I told here, so practically impossible to examine every individual, means we cannot examine the each and every point of that part of the sweet, means we need to just take one sample, means one piece, so the entire group is known. So therefore we may prefer to examine what here only small part of this population, means from out of the 10 kg only will take what here only one piece and will examine that. Out of 10,000 means out of 10 kg of sweet, if you take a small part, that is or small piece of to taste, that small piece is going to called as sample. So and that 10 kg of sweet is nothing but what here, a population. Means out of a large, so we are going to test only what here, only a small. So now right now, so COVID-19 is going on, so we are means here we are not going to we are not testing completely, means suspected, only few we are testing, means from that we are concluding. So that area supposed to be covered for means a seal down or lockdown, what we are doing, means so here based on a one individual we are taking one decisions. So based on that, such decisions will come under what here, this sampling theory. Means so I want to continue. Means practically impossible to examine every individual or the entire group known as population. Therefore we may prefer to examine a small part of this population known as sample, with the motive of drawing some conclusion. Means with the help of that we'll conclude that whether we need to take that sweet or no, means or what we are going to based on that we can say that, so that particular thing whether to purchase or no, so based on that small taste only, so we are going to purchase the population by a small part as known as sample with the small taste, and will conclude whether we need to purchase that population or no. So therefore I can say that, so some conclusions about the entire population based on information or results revealed by these samples, means based on the taste of the sample only you can say that, so what is the taste of that complete entire sweet, so or complete a result of that population is based on what here, a small testing or a small taste of that particular concept, which is going to called as what here, sample. The entire process known as statistical inference aims in asserting maximum information about the population with minimum effort and time. See, to purchase the 10 kg of sweet, so we are not tasting what here, all 10 kg. So we are taking just a simple one bite of that sweet, and will conclude whether we need to purchase that sweet or no. Means based on, means here, so to take that 10,000 sweet, we are not bringing a 10 2 or 15 members to taste each one. So we just, I'm tasting and I'm bringing. Means here it is a very small effort in minimum time. We are going to conclude that whether that given 10 kg of 10 kg of sweet is supposed to buy or no, based on that small test. So I can say that the 10 kg of sweet what is there is going to called as population, and that what taste we have done, we call it is sample. So we have, these are the two important concepts right now in this sampling theory, that is population and sample. This population is denoted as capital N, and this sample is denoted as small n. So based on, so out this sample is nothing but a small part of a population. So one more thing, this population is also known as universe. So based on this one more name as universe, we can call again sample only from the universe. So sample is nothing but a small portion of a population or universe. Now we'll see the next few more concepts in this sampling theory. Random sampling. Random sampling, in this we have a few more important small definitions which will be very useful to simplify the examples. A large collection of individual or numerical data can be understood as a population. So I can say the definition of population, very important. They may ask for the examination. So define population, sample size and all. So you need to go through this. A large collection of individuals or numerical data can be understood as a population or universe. Next, a small section selected from the population or universe is called a sample. Means we are taking only a very small portion. So that small portion what we are taking from the population or universe is going to consider as what here, sample. Next, the number of individuals in a sample is called a sample size. Okay, I'll repeat, the number of individuals in a sample is called sample size, and I can say that the sample size is denoted as small n. If the sample size, that is small n, is less than or equal to 30, this is very important point. If the sample size n is less than or equal to 30, the sample is said to be small. Otherwise it is a large sample. If the sample size is, means n value is less than 30, so I can say that it is a small sample, and or else we have, this is a sample only. If it is greater than 30, it is sample only, but we call it is large sample. So in the sample size we have two categories. One is small sample size and another is what here, large sample size. What large sample size is there, it is from the population only, but based on the number, that number is what here, 30 is going to consider as what here, small sample size, and more than 30 is going to consider as what here, a large sample size. Next, the process of selecting a sample from a population is called sampling. Means our topic is nothing but what here, sampling theory. Means we are selecting a sample from a given population is called as what here, sampling. The selection of an individual or item from the population in such a way that each has same chance of being selected is called random sampling. Means a selection of an individual or item from the population is such a way that each has same chance, means whatever means you take any piece from the sweet, so it has what here having the same probability or same chances, means chance means what here probability only, it doesn't have any different probability, it has what here same probability. So that is the meaning here of the sample, random sampling. The selection of an individual or item from the population in such a way that each has same chance of being selected is called as random sampling. So these are the few very important few concept or definitions I can say to solve the examples. So from the examples we can identify, so what is who is sample and who is population, whether that sample is having a large, it is a large sample or a small sample, we can identify by seeing the number from the given question. So before that we should know what is population or universe, what is sample, we should know what is sample size, and that sample size is 30 or less than 30 or greater than 30, and that what process we are applying is whether it is sampling process or no, we should know before applying for the any solution of the problem here. So we'll see the one more concept. Now as I told, population size will be denoted as capital N, sample size is denoted as what here, small n. So sampling where a number of population may be selected more than once is called as sampling with replacement. So this is very important point you need to remember. So we have the problems based on with replacement and without replacement. So here sampling where a member of the population may be selected more than once, means I can say that I have tested once one piece of that sweet. Again to confirm that, again I am using one more test, again I am using, so that is nothing but what here I'm selecting what here more than once. So that kind of concept is sampling is going to called as sampling with replacement. If a member cannot be chosen more than once is called as sampling without replacement. Means here, so I have tested only once and then I have concluded that whether to purchase that sweet or no. So that concept is going to consider as what here means without replacement. Only once I have tested and I have finalized whether to purchase that sweet or no. So in this way, so with replacement and without replacement of the sampling is possible here. So without a replacement means only once we have chosen, and with replacement means what here, more than once we have taken the samples, and such kind of concepts are called sampling with replacement and sampling without replacement.